Hey, I'm Milind, the lead product developer at Molecular Quantum Solutions. So today we're going to go into how to run solubility calculations with our Cebule engine UI and our Python SDK. So let's get started by going into the Cebule dashboard and hitting create task. Here we're going to run a solubility calculation and we're going to test the solubility of benzoic acid in water and ethanol. We're going to select the solubility task type. And here there are two options to run solubility calculations. You can use the COSMO-RS or the COSMO-SAC models. And this is going to depend on the sigma profiles you've calculated of your solute and solvents based on if you use the COSMO-RS or SAC model for those. And you can refer to our Cosmo and sigma profiles tutorial to see how to run those calculations. So you can just use one core for solubility because it's a quicker calculation. And here we're going to want to connect the tasks of the sigma profiles for our solute first and then for our solvents. And if you want to rearrange these, you can always just drag and drop so that the solute one is first. Now we're going to enter the temperature of the mixture. We're going to enter some information about our solute. So the melting point and the enthalpy of melting. And we're also going to give an initial guess of the solubility value, which is the molar fraction solubility. Finally, we're going to give the composition of our solvent. And here we're using ethanol and water as our solvents. So let's do a 60% water and a 40% ethanol by molar fraction composition. Now we can hit create task. Once that finishes, you can scroll down to preview result. And here we see the predicted solubility value as a molar fraction. If we use the COSMO-SAC model, we would also get a predicted uncertainty for this solubility value. Awesome. Let's now dive into how we can run solubility calculations and high throughput screenings via our SDK. So let's navigate to our Python SDK GitLab link. And here we can click on the scripts folder, which is going to contain our scripts that use the Cebule SDK to help run high throughput screenings. And here we're going to do a high throughput screening of solubility with an example data set. So first of all, you're going to want to create a virtual environment with Python and install the requirements for our scripts, as well as configuring your MQS credentials using a .env file in your current directory or home directory. With these credentials, we use the .env package to then load your credentials and log you into Cebule. You can scroll down on the README in our scripts directory for information on all the different scripts we have for descriptor calculations and machine learning. Right now, we're going to focus on the solubility calculations. So let's take a look at an example data set for our solubility. We can go back to the home of our repo and click on the data folder to see some examples. Here, in this example, we've defined the solute we want, which is benzoic acid, the solvent. So here we want to compute the solubility under just water, under ethanol solvent, and under a combination of water and ethanol solvent. We give some information about our mixture, the temperature, as well as some solute properties over here. Let's open a terminal and try running our scripts. So I've gone ahead and run these for brevity. The first one is our geometry script, where here we're going to optimize the geometry of all our molecules. So you can see here the benzoic acid, ethanol, and water geometries were optimized. And it's going to store the output in this optimized CSV. We can take a look at how that looks as well. And you can see for each of the molecules, we have the coordinates that were optimized. Great. So now we can go ahead and run some sigma profiles calculations. And this is going to involve first running Cosmo simulations with DFT and then running sigma profiles calculations. Here we're doing it with the COSMO-RS model. And we were using the sigma.py script for this. So you can see that for each of the different molecules, here's benzoic acid and then ethanol and water. We're going to do a Cosmo task as well as the sigma profiles calculations. And then the results are going to be saved to another CSV over here. And for the sigma profiles calculation, you'll notice that in addition to passing our normal dataset CSV, we're also passing the results from our geometry optimization. So let's take a look at these sigma results. So here you can see the sigma profiles for each molecule. Now, finally, we're going to go and run solubility calculations for this data set. and we're simply going to pass the dataset path as well as the datasheet with the sigma profiles results. And here we're now going to get the solubility predictions for each of the different mixtures with the COSMO-RS model. If you use the COSMO-SAC model, you'll get different values because these are different parameterized models. And this is what the resulting solubility sheet looks like from the solubility script output. You can see for each of the three mixtures we defined, there's the solubility from the COSMO-RS model because we use the COSMO-RS, and we have it both in a molar fraction and in milligrams per milliliter because we can convert to this unit using the component densities that have been given in the sheet. Great, so you're now ready to run your own solubility calculations with the Cebule engine UI and high throughput screenings with our Python SDK. Go ahead and give it a shot with your 25 minutes of free compute time on Cebule, and have a great day.